Let's take a look at some real-world applications of least common multiple and greatest common factor. So Andre is making flower arrangements. He has 14 roses and 21 daisies. If Andre wants to make all the arrangements identical and have no flowers left over, what is the greatest number of flower arrangements he can make? So we need to decide whether we'll be looking for a GCF or an LCM. So there are two things that we can look at. First off, we have the word greatest right in our problem. We're looking for the greatest number of arrangements. So that might clue us into wanting to use GCF or greatest common factor. The other thing that we want to see is that Andre is taking these flowers and splitting them into groups. So we're splitting into groups. Right, and that's what factoring does. Factoring pulls a number apart into into groups that when we multiply them together, right, we get back the original number. We can kind of think about it that way. So those are two things that we can think of that'll clue us into this being a greatest common factor problem. So we have 14 roses and 21 daisies. We're going to start by finding the GCF of those guys. So we can start with a prime factorization. 14 is really 2 times 7, and 21 is really 3 times 7. So when we find a GCF, we only take the common factors. So they both have a 7 in common, so that's what we're going to pull down. Okay. So what this 7 tells me is I can make 7 arrangements. All right, and what would these arrangements look like? Okay, so if I made 7 arrangements and I have 14 roses, that means I'm taking those 14 roses and splitting them up into 7 flower arrangements. So each arrangement would have 2 roses. And then we're taking 21 daisies and we're splitting those up evenly between 7 arrangements. So 21 divided by 7 is 3. So we'd have 3 daisies. All right. So Andre could make 7 arrangements, and those arrangements would have 2 roses and 3 daisies. It only really asked you about the number of arrangements, though, so the 2 roses and 3 daisies information is just bonus for us. Okay, 17. Sarah's shipping and Ryan's mail service both ship packages. Sarah's truck will only carry loads of 18 packages. In contrast, Ryan's truck will only carry loads of 10 packages. If both businesses end up shipping the same number of packages this morning, what is the minimum number of packages each must have shipped? Okay, so let's talk about whether this is GCF or LCM. So again, kind of a cue word that we can use is minimum, right? So GCF is the greatest, LCM is the least. So when we're talking about minimum or smallest, we want to be looking at LCM. Another thing that we might want to think about is how many packages we will be shipping, right? So Sarah, will she ever ship less than 18 packages? She will not. It says she carries loads of 18 packages, which means she's either going to be at 18, or if she does 2 shipments, she'll be larger than 18. So least common multiples are always greater than or equal to. So we want to think about that. So this is going to be an LCM problem. So that means we need to find the least common multiple of these packages being shipped. So where Sarah is starting with 1 shipment of 18 packages, and Ryan starts with 1 shipment of 10 packages, all right? So then Sarah does a second shipment, and now she's shipped 36. Ryan does a second shipment, and now he's shipped 20. So we're going to keep up this pattern, and we're going to see at what point do they meet up. So if Sarah does another, then she's at 54. Ryan would be at 30. All right, and we want to keep going. So if Sarah does another, she would be at 72. Ryan would be at 40. And another, we would have Sarah at 90 and Ryan at 50. Now you might notice something about 90. You might notice that 90 is divisible by 10, And you might want to stop there, and that's fine. I'm going to keep going with both of them. So Sarah would then get to 108. Ryan would get to 60. And then we want to keep going. So then Sarah would end up at 126 packages sent. Ryan would be at 70. Sarah would then be at 144. Ryan at 80. Then Sarah would be at 162. Then Ryan would be at 90. Once I hit 90, I can see that we overlap right there, right? At that point, they have shipped the same number of packages, right? So how many trips did it take Sarah? It took Sarah 1, 2, 3, 4, 5 shipments to get to 90 packages. It took Ryan 1, 2, 3, 4, 5, 6, 7, 8, 9 shipments. But if they shipped the number of packages, the smallest possible option would be for them to have shipped 90 packages. It just took them a different number of trips.